Hello, my dear student. Today I am going to discuss about physics chapter 1 physical quantities and measurement. Physical quantities and measurement. Physical quantities and measurement. In this chapter, we will try to introduce fundamental quantity, base quantity, SI unit, multiple and submultiple. Measurement is related to most of our daily activities. The act of measuring something is called measurement. So the act of measuring something is called measurement. In this chapter, we will discuss measurement, unit of measurement, international system of units, some measuring instrument and their uses. In almost all the experiments in physics, it is necessary to measure different quantities. So that's why measurement is very important in physics. First, we have to learn about what is physical quantities. Physical quantities. Physical quantities. Anything that is measurable, anything that is measurable, in this physical world, is called physical quantity, physical quantity. For example, the length of a table can be measured. So here length is a physical quantity. So the mass of your body can be measured. Mass is a physical quantity. The time during which you are reading this book can be measured. Time is a physical quantity. If you apply force to lift some things, that force can be measured. So force is a physical quantity. There are many such quantities in the physical world. According to the dependency, physical quantity are two types. So types of physical quantity. Quantities. According to the dependency, physical quantities are two types. One is fundamental or independent quantity. Independent quantities. And number two, derived quantities. Among these, it is seen that there are few quantities which can be measured without any help from any other quantities. These quantities are known as fundamental quantities. For example, to measure the length of a table, you need to measure only length. To measure this length, there is no need measuring any other quantity. So length is a fundamental quantity. So length is a fundamental quantity. So first we have to learn about what is fundamental quantity. The physical quantity which does not depends on other quantity, rather other quantities depends on them, is known as fundamental quantity. So fundamental quantity, number one, fundamental quantities. So the physical quantity which does not depends on other quantity. So the physical quantity, physical quantities which are independent or neutral that is they do not depend on other quantity, other quantity. Rather other quantity other quantities depend on them are called fundamental quantities. So length is a fundamental quantities. Why length is a fundamental quantities? Because to measure this length, there is no need of measuring any other quantity. So length is a fundamental quantity. Mass is a fundamental quantity. Scientists have identified seven such quantities. They are length, mass, time, temperature, electric current, luminous intensity, and amount of substance. So scientists have identified seven such quantities as fundamental quantities which are used in all branches of science for measurement. These are number one, length, number two, mass. Number 2, mass. Number 3, time. Number 4, temperature. Number 5, electric current. Number 6, luminous intensity. Luminous intensity. And number 7, amount of substance. So there are 7 fundamental quantities. These quantities do not depend on other quantities, rather other quantities depend on them. Now, number 2, derived quantities. Number 2, derived quantities. The physical quantity, the physical quantities obtained from fundamental quantities are called derived quantities. Like velocity, acceleration, example velocity is a fundamental quantity. Why? Velocity equal to displacement divided by time. Displacement means one kind of length in a particular direction. So velocity depends on length or displacement and time. That's why velocity is a derived quantity. Acceleration is a derived quantity because acceleration equals to change in velocity, that means velocity divided by time. Again, velocity means displacement divided by time, so displacement divided by time squared. So time squared. So acceleration depends on displacement and time. That's why acceleration is a derived quantity. Force is also a derived quantity. Why force is a derived quantity? Okay, force is a derived quantity. Let's check. Force means mass into acceleration. Because we know F equal to ma. M here mass and a is the acceleration. So mass is a fundamental quantity, but acceleration means velocity divided by time. Again, velocity equals to displacement by time. So mass into displacement divided by time square. So force depends on mass, displacement and time. That's why force is a derived quantity. Derived quantity. Now measurement. Now measurement. Uh, what is measurement? What is measurement? Measurement, measurement. The act of measuring anything is known as measurement. So the act of measuring, the act of measuring something in our daily life, daily life is called measurement. Measurement is related to most of our daily activities. Moreover, we need accurate measurement for various research works. So the act of measuring something in our daily life is called measurement. In general, measurement means the act of determining the quantity of something. Quantity of something. For example, the distance of the school from your home is 700 meters. Shoel has bought 5 kilometers of rice from the shop. We need two things to measure anything. One is number, which is known as magnitude, another is unit. So unit of measurement. Now unit of measurement. A standard is essential comparing with which any measurement is done. Any measurement is done. These standard quantities are called unit of measurement. These standard quantities are called the unit of measurement. Unit of measurement. Say the length of a rod is 4 meters. Here meter is a unit of length and 1 meter is a specific measurement. Therefore, length of the rod 4 meter means length of the rod is 4 times of 1 meter's unit. There are different unit of measurement of time, volume, velocity, mass, force, energy, temperature, electric current. These units have been designed in such a way that they can be convenient and can be easily and accurately reproduced. So there are some characteristics to specify unit of measurement. So this unit of measurement have been designed in such a way that they can be convenient and can be easily and accurately reproduced. Now, fundamental unit in SI. SI means System of International. We can can select fundamental units according to your liking, since the units of fundamental quantities do not depend on other units. But our selection must have international recognition. It should have some characteristics as well. For example, it should be unchangeable, that is independent of place, time, and person. It will not change due to the passage of time or any other natural change. The standard of fundamental units that were accepted in 1960 while introducing the SI system of units.